Amazon Simple Queue Service, or SQS, is a fully managed message queuing service provided by Amazon Web Services. It enables distributed applications to communicate asynchronously by sending, storing, and receiving messages between different software components. SQS is a fundamental building block for building decoupled and scalable cloud architectures. SQS is a fully managed message queue that facilitates distributed queuing between application components. It allows different parts of your application to communicate without being directly connected. The service enables asynchronous processing, meaning applications can send messages without waiting for an immediate response. This decoupling allows each component to operate independently, improving system reliability and scalability. SQS provides several important benefits. First, it offers high reliability by storing messages redundantly across multiple availability zones, ensuring your data is protected even if one zone fails. Second, it provides automatic scalability, handling any volume of messages without manual intervention. Third, SQS includes robust security features with encryption both at rest and in transit, plus IAM access control for fine-grained permissions. Finally, it's cost-effective with a pay-as-you-go pricing model, meaning you only pay for what you actually use with no upfront costs or commitments. SQS offers two types of queues to meet different use cases. Standard queues provide unlimited throughput, meaning they can handle as many messages as you need. However, they offer best-effort ordering and at least once delivery, which means messages might occasionally arrive out of order or be delivered more than once. FIFO queues, which stands for first in, first out, have a limit of 300 messages per second, but they guarantee that messages are processed in exact order and delivered exactly once. Choose standard queues for maximum throughput, and FIFO queues when message order and deduplication are critical. The SQS workflow involves three key components. First, a producer, which is your application or service, sends messages to the SQS queue. The queue then stores these messages reliably until they're processed. Finally, a consumer, which could be another application, Lambda function, or EC2 instance, polls the queue to retrieve and process messages. This separation allows producers and consumers to work at their own pace, making your system more resilient and flexible. Understanding a few key concepts is essential for working with SQS. Visibility timeout is the period during which a message becomes invisible to other consumers after being received, with a default of 30 seconds. Message retention determines how long messages stay in the queue, ranging from 1 minute to 14 days, with a default of 4 days. Long polling is a technique that reduces empty responses by waiting for messages to arrive instead of returning immediately. Dead letter queues capture messages that fail processing after reaching the maximum number of receive attempts, helping you identify and troubleshoot problematic messages. SQS is ideal for several common scenarios. You can use it for decoupling systems, separating your front-end from back-end processing so each can scale independently. It's perfect for implementing work queues, distributing tasks among multiple worker instances for parallel processing. SQS excels at batch processing, queuing data to be processed at scheduled intervals or when a certain volume is reached. It's also valuable for load leveling, buffering incoming requests during traffic spikes to prevent your system from being overwhelmed. Getting started with SQS is straightforward. First, create a queue by choosing either standard or FIFO type and configuring your queue settings like retention period and visibility timeout. Second, send messages to your queue using the AWS SDK, command line interface, or management console. Third, receive and process messages by polling the queue from your consumer application, processing each message, and then deleting it from the queue once processing is complete. This simple workflow forms the foundation for building robust, distributed applications on AWS.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.